I'm Tobias, or in Danish, Tobias Due Munk. Tobias Due Munk, call me whatever you want. Yes, Due does not mean you, it means pigeon, and Monk does mean monk. I didn't bring my costume, but I'll try to do that next time. Just quick advice on Barcelona. Have anyone taken the metro here? Many people, okay. So we do have metro in Copenhagen. Of course, things are just simpler. But you get those T10 pass or like tickets. You go there and you put it in the machine and you walk through. And they have these glass gates that open and close. When you're bringing your kid in a stroller, it's kind of scary. Like, does it count persons or objects? So you're kind of making yourself like one object going through the gates and going it very fast. I had an issue yesterday, and this is a word of advice. If you go to a machine that is not the glass doors, but one of those like triangular rolling metal bar thing, you put your ticket in and you go to it and just boom, like you can't go anywhere. And you try again and again, and I bought another ticket because like maybe it was just used. Like maybe I spent all of the rides that I could do on that ticket card. It turns out maybe you should go on the other side of the machine. So do that. I'm here to talk about depth sensors and how they can be used for augmented reality, AR, on mobile, under the title Into the Deep. I'm a developer and designer, one of those few people that raised my hand as like we were 5 people raising our hands. We are designers and developers during the first talk today. I think more of you are, you're just not really aware of it. So, because I mainly work in iOS, all the examples are going to be iOS, the code examples are going to be Swift. I'm running this talk on an iPhone 10 to be able to show you all the good stuff. I always want to go onto stage to music. Few conferences do it. It's tacky. Woo! Thank you. Yeah, it's good they're turning down the music a bit. It's a bit loud. Okay, so just a quick intro before we go into what it is. If I'm moving my hand closer to my phone, this square becomes bigger and bigger. And when I move away, it becomes smaller again. There's a sensor that can sense the depth. So let's get started. You can capture depth as single-frame photos. But in this talk, I'm going to live stream all the things. Most things can be applied to both domains, but of course, some things make more sense in one domain or the other. Let's look at how it's actually done in code. Most parts of Apple's depth APIs are provided by the AV Foundation framework. Capturing data is for the iOS, for iPhone only, so far. And manipulation, like working with the data, can be done on both iOS, macOS, and tvOS, meaning Mac and Apple TV. So both the front camera on the iPhone 10, that is the depth sensor, and then the dual cameras on the back of both the iPhone 10 and on the plus-sized iPhone 7 and 8 have depth sensing capabilities. Here I'm setting up a discovery session that is looking for a true depth camera or a dual camera, and I want video. I want it to be live, to be fun. So we ask for some devices based on these requirements that we put up, that we want depth. We select one of the devices, and then we create a session, and we add the input to the session. Now we want to have data out of the session. We create a depth data output, add it as an output to the session, and then we put on a delegate on the output to get a callback every time we have a new frame of depth data. So this is called every single frame where the depth data comes in. The only thing we're interested in here is the depth data part. It's an AV depth data object. Just give you a bit of a look into what it contains. It basically has a buffer inside full of pixel values representing the distances in a pixel grid. Just as you know from a photo that has colors, this buffer has values for depth instead. This kind of buffer might be familiar to you if you've been working with video or photos on iOS platforms or other Apple platforms before. So the default format for the buffer is a bit peculiar. So here we're just converting it to a float 32-bit format, and it just means that every single pixel is just one floating point value, and it's very easy to access in Swift. Or easy is a stupid word sometimes. This is what it looks like when we want to get a single value. I know this is a bit much, and for some of you it's probably way too much, but watch and learn. So first, we have our buffer, and we cast it into an array of floats. Then we calculate the index in the buffer. The buffer is like one long array, and we're used to having a pixel grid with x and y's, or a matrix. So we're going into one dimension instead. So we're using the width of the buffer or of the picture to calculate the correct index. When we have the index, we need to remember to lock the buffer before reading from it, else bad stuff happens. And then finally, we can actually read out the value for a single pixel. Here, 1.337. But what does the pixel value actually represent? So we need to introduce a little bit of new terminology. It's very limited. It's just one word, and the word is disparity. When we get data from the depth APIs, it's usually disparity. We can convert it into depth, but disparity is the most raw thing we can get. And disparity is just the inverse of the depth. So as you can see here, when we are at 1 meter distance, both the disparity and the depth has a value of 1. So 1 meter, and the other one is 1 over meters. And then when we go closer to the sensor, we get a bigger value for disparity and a smaller value for depth. And when we go in the opposite direction, the disparity decreases towards 0, and, well, the depth goes to infinity, depending on how far away we go. So when you're working with these things, talking about these things, make sure to know if you're talking about disparity or depth. It's very easy to get confused about it, and particularly in code, it's very helpful to be very clear about you're working with one or the other, because else things are just inverse. So let's see it a little bit more in action. Are you ready? Maybe? Yes. Cool. OK, so let's do a quick comparison between the two types of camera that can capture depth. It's the true depth camera and the dual camera in a fierce showdown. So what you've seen so far is the front sensor. It uses an infrared transmitter and receiver, so it works really well in dark. There is no background light needed. So let's take a look at how it looks for the dual camera. I have it set up so it should kind of work-ish for this. And we have some light on the audience. Can someone wave in the audience down here in the front row? You can see some things happening. But it clearly shows, well, the dual camera really isn't that good for live streaming video and looking at, or to actually be able to capture good data. So it uses the stereo effect from having two cameras, and it uses that to infer the depth. It performs really bad in low lights. And for live streaming, the quality is quite low in general. I think it's like processing intensive to actually infer the depth from the stereo data. But for static photos, it's quite good. So you might have seen that in different places where it actually performs quite well. But for live streaming, it's just not so good. OK, so my phone is running hot, and the API are telling me that the phone is running hot because I'm using the sensor all the time, or almost all the time. This sensor is really not that ready for mobile use yet, or at least not for continued use. So if you're considering use cases for this to use today, consider that. It's not able to run for 10 minutes. I don't know how far I'm into the talk now, maybe 10-ish minutes, without actually starting to heat up a bit too much. And we're even inside. There's no sun heating the device up as well. So listen to these alerts and be sure to kind of consider the use case where it is going to be used and how you're going to change your interface depending on if the feature is actually available. Like it just might stop not being available at some point. So please listen to those alerts and see how you can throttle maybe the frame rate or something like that. OK, so back to the kind of defined parts of the talk instead of all the alerts. So filtering is one of the few things that you can actually set on the input. On the output. So you can change if you want to have filtering or not. And as you can see here, filtering disabled, there are some spots in the data where it basically just doesn't know what the distance is. So you can say that it's failing, it cannot detect. And of course, this is something that is bad at large distances because it's actively sending out infrared signals and then reading it back. So it doesn't work over big distances. Here it works OK, but if you're outside, then most of the background will just be black. So one thing you can see is that if I'm holding my hand in front of myself here, and there is kind of a shadow on the lower side of my arm. And that's because the IR transmitter is located in a little bit different position than the sensor. So there's kind of like a shadow effect where the right eye can see what the left eye can see, and therefore it has like a shadow along one axis. So also be wary of that. You can see here, if I'm putting my hand really close to the device, it's failing as well. So it's down to like 15 centimeters, like half a foot. It fails. So it doesn't work at large distances, like more than 5 meters, and it doesn't work closer than 15 centimeters. And now I've re-enabled filtering, and you can see that all the black spots are gone. When I'm moving my hand really close, you can see that it fails differently. Instead of giving me invalid reading points, it just defaults to like a 0 distance, meaning infinite. So that's something that you have to consider. Like, should you use filtering or shouldn't you? And if you do use filtering, then you do lose some information about was there even a reading, or is it just an interpolation between different points in the data set? So you might want to roll your own filtering. OK, so let's move along and add a little bit of old school color to the mix. So just as before, where we added depth outputs to our capture session, now I'm adding a video output, aka color, to the session. We could add a delegate callback for the video output as well, but then suddenly we have 2 callbacks, one for depth and one for the video data, for the color data. So fortunately, AV Foundation has a synchronizer that we can use that kind of keeps things in sync and makes sure that we get everything in one package, instead of those async packages from Amazon where you get one thing one day and another thing the next day, and then for one day you can't use the first thing you got. That just sucks. So we just want to synchronize things and get things at the same time. So sorry about that. So we have our 2 outputs. We initialize a synchronizer with those 2 outputs. And then we can just add a single callback. Delegate sets callback to that one synchronizer. And then we have this function called. I know, it's a bit messy. just as before, this is the only thing that we're interested in. We get a collection of synchronized data. Thank you. So let's just look at how we unpack this synchronized data collection, because it's a little bit tricky. It's basically a dictionary where you can subscript using our outputs. So we're subscripting, for instance, for the depth data outputs. And then we're also casting it to an expected type. So we're expecting AV capture synchronized depth data. Don't worry so much about it. It just, if you're going to use this, it's nice to see kind of what it looks like and how you need to unpack things. So depending on the use case, you might want to not, or you might want to discard data when one of the two inputs are, or the two outputs are dropping. So if depth data is failing, you might not want to look at your color data, because then suddenly again you have out of sync data, because some of the data might be old. So here we just check for it if please no one drop anything, and then if it actually didn't drop, then we can continue. So despite some convoluted code, we finally have our depth and video data perfectly aligned. So you can see here, if I'm moving closer, you can kind of see some colors added to the depth. OK, so resolution, like what's up with this? The module is thinking, give me a little break. Should we have a little break? Oh, this is the one, right? OK, sorry about that one. Other kids in the audience, maybe they should go home. OK, so you might be wondering what's up with the resolution. Is the tech really as lo-fi as the 80s? So here I'm digitally zooming in on my right eye. Wink, wink. But this actually doesn't show the full extent of the resolution. So let's go one step further along the scale of using embarrassing facial features and blowing them up on the big screen. So here is my nose. And if it can pick it up, like that. What you see here is the raw data. There is no interpolation done between the different points. And what you basically can see here, that each pixel has a different value, or you might be able to get it from the screen. So the resolution is VGA. It could be much better. Hopefully, in the couple of next years, we'll get even better sensors. For now, that's what we have on the front. And for the back, it's only a quarter of that. But as I mentioned earlier, the quality, anyways, is so low from live streaming from the dual camera. So maybe just don't even consider that if you need live streaming. So before we go, it's kind of interrupting, right? So before we are going deeper into the data, the depth data itself, let's have a little bit of a look at a higher level API that uses the depth data. Introducing ARKit. So we saw some things earlier today about augmented reality. This is one of the ways to do it on iOS. This is only on iOS, ARKit. So the setup of ARKit is very similar to what we saw before for video and for depth. So we make a session, and we add face tracking capabilities to the session, and then we run it. And then we add a delegate to it to be notified when changes are happening. And here we have a delegate callback that contains anchors. So these AR anchors, these are also used for image detection and for plane detection and other things. So we kind of need to unpack this one as well to get what we want. We want AR face anchors. So that's what the code does here. It just unpacks it. It finds one of those. So when we actually take a look at one of our face anchors, this is one of the things we get. So we get a basic shape geometry that we can just render in 3D. I don't do anything special here. I just take the geometry, add it to whatever object, and render it in 3D. I don't deal with any animations or strange values. It's very simple and straightforward API. Bop, 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 bop. So this is the stuff that runs animojis, as you can imagine. So it's a simplified, I need to be down on my knees here. Okay, so it's a simplified mesh of your face, but it adapts if you have like a round or elongated head or like different weird shapes. So maybe I can try and provoke it to do that here. So if I'm putting my hand on my chin, maybe you can see that it's growing a little bit. So you can kind of fool it to change size. You can also do it on your forehead maybe. Bigger forehead, yeah. So like if you're switching between different persons, it actually changes their shape a little bit. And if you render it on top of video, you can kind of see that it matches quite nicely. So even though it's a simplified shape, it does actually adapt to different individuals. So the AR face anchor doesn't only have the geometry. It also has a bunch of facial details that are called blend shapes. And specifically, this is what is actually powering Animojis and Memojis. So there are 50+ different values for things like brow position, your eyes, if you're sneering with your nose, whatever that means, and how much you're squinting on each eye. So blend shapes is just a bunch of numbers for each of those different types of values. So here I'm just having like an auto snap for the perfect selfie when I'm doing a duck face. So this is an app idea right here. Like this is a full app. Take it, use it, build it. Take it for free, completely free. And please make the app free. Okay. Okay, so just another small demo of what you could do with these blend shapes. The frame rate seems to be a little bit low, maybe. Now it works fine now, okay. This is how musicians are going to work in the future. Ah, that's fun, right? Okay, so a couple of new things that were added in iOS 12, or is in the beta of iOS 12, is that they also track eye position. This is something that actually doesn't use the depth sensor, but it's in the APIs, it's kind of fused together. So if I'm holding my head still here at a good position, if I'm looking right, left, maybe it works-ish. Does it work? I can't see it when I'm looking around. Does it work? Ish? Okay. So, of course, I had to use lasers for this. That's just how things are. Okay. So it also, in the API, provides something called a look at point, where it kind of tries to predict where the people are actually looking at in 3D. So my implementation of this is not that good. I saw someone on Twitter pushing a demo of how to actually control an interface doing this. But just to give you kind of like a small peek into what it does. OK, now the frame rate is throttling. I'll just restart the app, and hopefully that can help things. Does this help? There we go. OK, so when I'm looking right now, the ring should be moving a little bit to the right. Does it do that? No? Oh, it does a little bit. OK. This probably is something that then actually works better in a more well-lit scene instead of something like this. Well, there's a lot of lights, but I might get a little bit confused. So this is something I find really interesting, to actually control your device using like where you're looking at and when you're doing it. So you could both use this for like hands-free control, or if you have a disability of some sort, then you can it might be able to help you. And it just comes for free on a very expensive iPhone. Very exciting. OK, so just another look at what we can use the depth sensor for when we're as an input. Imagine that the left side of the frame is kind of used for changing the note that is played. Again, musicians of the future today. And then we also change like the filter of or the shape of the sound a little bit using. OK, there's an error in here. It's from the right side of the. of the screen. So let's just see here. It looks like the future, right? Okay, on to some of the last parts of the talk here. A typical thing that you would want to do with your depth data when it comes in is to normalize it. So that means that you have values going from 0 to 1 instead of having them going from 0 to whatever big value. So this is very useful if you want to show a preview of depth data, that you can kind of show it in as high contrast as possible, but without clipping any values. And it's something that I've used quite a lot of times when I'm going to work on the data, so it's often nice to just know that where data are, they are normalized, and then you can work with it from there. Okay, so some of the next parts will be a little bit code heavy, again, but hopefully some of the demos will soften the blow a little bit. So in the beginning, we saw something about how we can read data out from the buffer, and now we want to normalize it. We actually need to read data back into the buffer. This is very similar to what we did back then. So there's a bunch of conversions going on. Then we calculate the index, and then we can just set a new value back into the buffer. And of course, we need to remember to lock it before we actually write back into it. OK, so to the actual normalized function, first we want to find the min and the maximum value. This is homework for next time for everyone. And when we have those values, then we can calculate the range of all the values. Then we can loop over all the single pixels in the frame, read the current value, calculate a new normalized value, and then just write it back into the buffer. And now we do have a normalized buffer. So just before I'm actually showing you the normalized output, this is the raw data coming in. And this is the disparity. So that means that values closer to 1 meter will have values bigger than 1. And the way that it's rendered here means that a value of like 100% white is equal to 1 meter. So anything closer than 1 meter will have values higher than 1. So it's just white, and it's just clipped. And that's not what we want. What we want is something like this, where when I'm putting my hand really close, you can see that it will stay white, but I will turn more like 50% gray or whatever. OK, so you can see the frame rate really isn't so good here. So let's bring on a very awesome photo processing framework called Core Image that can help us do this normalization. It uses the GPU, so it's often much more performant. And it's available on these 3 platforms. This is one of my favorite frameworks to work in on iOS. It's very, very powerful. So Core Image has a CI image data object that you can initialize with our buffer. It's just backed by it, so it's very fast at initializing. And then we need to have a filter that actually gets the minimum and maximum value for us. It's called CI area min max red. And the interesting thing is the way that it outputs data back to us and tells us what the min-max values are by giving us an image. The image is a 1-by-1 pixel image, and the way that it's stored is not documented by Apple. So if you need something like this, this is where you pay attention to my talk. Then you can go to sleep again afterwards. So what we're doing here is that we're rendering the 1-by-1 pixel image using a CI context into an array. The format of the array, as you can see, the format is RGF, meaning that it's red and green. So each pixel contains 2 values, one for red and one for green. And the first value means minimum, and the second value means maximum. So red min, green max. Kind of strange. Need to unpack things. OK, so now that we have those min-max values from Core Image, we can use, again, a filter in Core Image to actually normalize our data. So we use a color matrix where you basically define a slope and a bias, as you can see here. add it to the filter, and then it will apply the calculations for us on the GPU. So it's really fast and performant. The calculations here look a little bit different than before, but in the end, the math is the same, and we end up with a similar result. So here we have normalized data using the core image framework instead, and you might notice that the frames are dropping a little bit less at least, and at least I can promise you that the CPU usage is way down. So even though it's using GPU a little bit more, it's much more efficient, and it will drain the battery slower. Still fast, but slower. OK, so let's just look at a few examples where I'm using core image to do some different things. These are the final examples of the talk. So I'm not going to show full code again here, but for this next effect, I'm using two color matrices that is kind of creating two opposing slopes, and then it can kind of scope out parts of the depth data. And it's combining the two together using a blend filter. So darken blend is like similar to what you have in Photoshop. So imagine two grayscale images, and you blend them together to get the result that we can then see here on the next slide here. So you can see I'm basically zooming the center point for the two slopes, like going through the image. So if I'm holding out my hand like this, I would just wait a bit. You can kind of see it scanning through the depth data. So these are things you can very easily do in core image. At least it's much harder to do on your own. OK, so here I'm just adding a small edge detection filter to on top of this. So what you see here is kind of like a halo effect from the depth data going through it. And this is something that like an app like Halide, a camera app on the iPhone, uses for their depth preview. So they can overlay this on top of the color data, so you can kind of see depth along with depth data. And I think it works really well. OK, so finally, a very common thing that you use depth data for is to blur the background of photos to make it look more pleasing. Portrait mode is just that, and it's built into the stock camera app on iOS. There are similar things on Android as well. So the filter behind portrait mode is CI depth blur. Hi, me. And it takes color, image, and disparity. I can point. That's awesome. So where is it down here? Yeah, so it takes the color image and the disparity here. And then it creates an output. So let's just see what it looks like. So here you can see my face is still in focus, and the background is blurred somewhat. And if I move my hand in front here, you can see like this, my face is still in focus because it can detect a face, and by default, it always focuses on faces. It's called portrait mode. So what you can see here is that if my hand gets in front of my face, the camera doesn't detect a face, and now it just defaults to focus on the thing that is the closest. So if I move another hand out here that is closer, then it doesn't really do it that much, and then it crashes. Reopen. OK, so you can kind of see that it does some automatic stuff, but we can, of course, force it to do exactly what we want. So here I'm putting in a focus point and saying I want you to focus on this point. And the point that I'm putting at is in the one of the corners, either top right or top left. Let's get to that in a second. The code here really isn't that interesting. We're just saying this region in the photo should be in focus. So now that we've added this focus rect, it disables the face detection. So it just always tries to focus where in the right side of the image, so it's my left hand. So you can see here my left hand is in focus when I'm moving it closer here. So if I'm putting it at the same level as my face, like this, you can see my face is in focus and the background is blurred just a little bit. OK, so you can change some values. Aperture is a thing you might know if you're somewhat into photography in terms of how much you're blurring the background. So it has an inverse relationship to the blurriness. So here we're showing what happens when you have a value of 22, which is the max value. You can see that the background is barely blurred, but if I'm moving really close, you can see that there is still actually some blurring of the background going on. And then we can move to the other end of the spectrum, where you're just saying aperture of the value of 1. And what you can see here is the background is blurring very, very much. And you have a very shallow depth of field, and everyone knows that everyone likes that. That's all I have for you today. Thank you. So, shut up. So tutorials and guides online are always a huge help when we're working on things in our field. A special thanks goes out to Simon Gladman and to Ray Vendelich and to Dragos Holban. I want to mention Halide app is awesome. If you are into working with this data and you feel like all the code stuff is too much, buy the app, you can export the depth data, and then you can work with it in Photoshop or other tools, and then you can kind of play around with it there to see how it works. So go buy that app. The next app you should buy is one that I made, which is basically allowing you to edit portrait mode photos on the iPhone. It's called Slør, and all the Mac sounds that I used in this talk is from pingy.com. Open source is always a big reason why we can work efficiently, both as developers and as designers. So here's a shout out to 2 of the frameworks that I used in my app. I also use a lot of other ones, but a special thanks to these 2. They helped me through some tough spots making this presentation actually work. So, yay, open source. Thank you. Just a quick thank you to the tech crew. They are somewhere here. They worked hard to make this work yesterday and for the setup for the talk and everything, so give a round of applause to the tech crew. Okay, any questions?
Hi. So are there any examples of apps that are using deep sensing technology, to your knowledge?
No.
Really?
Hopefully more tomorrow.
So animojis are the peak of the technology?
I think a lot of it is kind of signaling what's coming. Apple is usually very adamant about what stuff they put into their phone. It's a very expensive thing to put in a new sensor like this. A lot of the other sensors are very low energy and very simple, like accelerometer, gyroscope, and those things. And this is VGA sensor, so a lot of data coming in. As I mentioned, it uses a lot of battery, it runs hot. So I think it's something they feel like is needed at some point for whatever glasses or whatever they do, AR stuff. It's really impressive how good the sensor is, how stable it is when you don't drive it too far. So yeah, in my opinion, it's one of those things where let's wait and see what they do with it, and maybe that's an awesome thing. I don't think they will put it into their phone and if they don't have a use for it. Maybe it's just making it better, and then they can use it in glasses at some point. I don't know.
Thanks.
Thank you.
Hi. Thanks. This was just an amazing presentation.
Thank you very much.
First question has been answered yet, but I have another one. How do you think? I suppose that currently this sensor is not so applicable for business stuff, but maybe it can be replicated by some external cameras from MacBook cameras, for example. How do you think? Can we just compose a similar buffer of bytes or float data and then processes with provided frameworks? Is it possible?
Yeah, definitely. Like if you look at the Kinect from Microsoft, it's basically the same technology, but it's this size. Now it's this size. So for me, it becomes interesting because now it's in mobile, and that's the field that I work in. So it's something that used to be huge, and now it's very small and inside not everyone's iPhone, but a lot of them, and hopefully soon even more. So it's just something that it's basically just a new thing that we can use, and I think there's so much to learn by going back and looking what other people have done. And you can do something like you mentioned to do something external thing, but that has existed for a long time. So the new thing is kind of having it in the phone. So hopefully we can kind of find something to do until they put it in glasses or something else. But yeah.
Actually, your example with producing music with proximity sensors, was looking quite interesting. It's not a new idea, of course, but there are no worldwide known examples of making music, professional music with this technology. I think it's area which are subjected to development.
Yeah.
Are you making any steps towards this?
No, I'm here to multiplicate, right? So like you have to do all this stuff. Now I've shown it to you, and you have to build it, and then I can go home and not do anything.
Okay.
No, but there are many things that you can do, and I think it's a really interesting thing. Hopefully you have a better view of what the depth sensor can do now and what stage it's at. That's kind of my main thing to kind of get out here. And then it's also, this is mostly just gimmicks about like things you could do. Hopefully it inspires you a little bit to do something. But yeah, it is like, what is it used, like what can you use it for? And yeah, I think we still have to wait and see what is like the main use of it.
Oh, okay, thanks.
Thank you.
Thanks for the talk, Tobias. Pleasure to watch you. Are there any new changes in iOS 12 related to the depth APIs?
Yes, there are a few. I shouldn't keep you from the coffee. That's always the joke, right? Okay, so there are a bunch of them, and they're still rolling in the beta. Just in the latest beta, they added some new things. They have, I think they call the portrait matte, which is basically the depth data, and then they look at the color data to say there is a person, and then they create a silhouette based on that. And it's something that is really easy if you want to make like an Instagram filter app or something like that. You can very easily get started by just using the portrait matte instead of using the depth data, because the depth data is not normalized and it's not perfect along the edges. And when they're creating the portrait matte, they are using machine learning and other stuff to make it even nicer in the edges. It's very similar to what Google already has in their portrait mode. I don't know what it's called, but their Pixel phones with the dual sense, the pixels and whatever. They do some similar things to kind of improve the depth data through machine learning and by using the color data to improve the quality of the depth data. Because it's looking at the same thing, the sensors are very close to each other, so it's easy to do. And then they also have a few other things. They have a few things related to the portrait matte, and then they had the eye tracking and where you're looking at. They also have tongue. I didn't show that. Emojis, or Animojis now have tongue. That's awesome, right? It's going to change the world, I tell you.
Thanks.
Okay, so I'm only here today. I'm not here tomorrow. So if you have any more questions to me, please approach me today. Blue boat all the way.